Let's see the implementation of binary search tree. So this is a very wide topic to discuss. So let's see the overview of binary search tree. Basically, what is binary search tree? So binary search tree is a tree where it has a root node and it has the two child nodes, that is the left child and the right child. And this is just a presentation of binary tree, okay? But if you need a perfect binary search tree, then the left child will also have two children and right child will also have two children. So this is again a left, again a right, again left, again right. So this is basically a perfect binary search tree. A perfect binary search tree is a tree in which every internal node has two children. Every internal node has two children and the leaf nodes are also present at the same level. So all these are called the leaf nodes. So these are some terms. Okay, these is called as a node. These are the nodes, and node consists of some value, like you can have value of 10, you can have value of 5, you can have value of 15, something like that. We will go step by step. Just try to learn what is the diagram of what is binary tree basically. So it consists of nodes, and nodes, the first node is called as a root node, and then these are the child nodes. These are nothing but the child nodes. Again, these are the child nodes. So binary tree has a left child and a right child. Binary tree has a left child and a right child, and this left child and right child will again have two nodes which are called as leaf node. Why are these leaf node? Because they don't have any children, they don't have these any children, so they are just having no children. That means they have a null nodes, right? So these are called as a leaf node. So another terminology for binary tree is nodes and leaf nodes. So nodes consist of what? Nodes consist of root, left child and right child. This is called as a presentation of simple binary search tree. Let me just rub this, maybe it is more. So let me give you an example. This is A, this is B, this is C, this is D, this is E, F and G. So A is the root node. Again, A is the root node. B is the left child. C is the right child. Left child, and this is the right child. So, if you are getting confused with the one which I have, okay, so B is the left child and C is the right child. This is what is the common presentation of the binary search tree. And these, what are these? These lines which are connected to each other are called as edges. These are nothing but the edges by which you can traverse the entire binary search tree. Now, why binary search tree representation is this way? Because it helps in searching any element or any value. So let me tell you that also. Um, so if you have over here 10, then you have 5, 3, take it as 9, then take it as 20, then take it as 16, and take it as 21. Okay, so if you see, each node is having the values. Each node, that is the root node, this is a root, so it has a value. Then left child is having a value of 5, right child is having the value of 10. So coming to the Logic of binary search tree. What is the logic? Okay, simple logic over here is left side of the tree, left side of the tree is always lesser than the root value. So if you see the root value is 10, right? So root value is 10, but the left child is 5. So it is lesser than 10. Again, if you go down, the left child is 3. Three's parent is 5, which is again less than 5, and 3 is also less than 10. So we are still good because this is the left side, right? Left side should be always less than the root value. Left side should be always less than the root value. Now let's see 9. 9 is towards the right of 5. So right side is always the greatest. Right side is always greatest. So since 9 is towards right of 5, it is greatest to this particular root. But 9 is less than 10. 9 is less than 10 because for 10, 9 is towards the left side. This is the left side of the tree. So it is less than the entire main root value. Same logic is for this right side. Right side logic is not less than, it should be greater than. So each node is greater than its own root. So 20 is greater than 10, which is a right side. 16, now we'll come to 16 little later because there's again a different logic. Wait. So let's come towards the right side of 20. We have 21, which is greater than its root. What is its root? 20 its root. So it is greater and it's towards the right of 20. So it is greater. Even this 21 is right of 10, which is the main root. So it is greater. So we are still good. What about 16? 16 is less than this root because it is towards the left. If you see 20, it is towards the left of 20, but it is towards right of 10. It is towards right of 10. So 16 is greater than its grandparent, right? It is greater, but it is lesser than its own root because it is again towards the left. It is again towards the left. This is just a simple logic of binary search tree, and this is very important. The left child are always less than the root, and right child is always greater than the root. So uh, and this is like a must for perfect binary tree. So the first thing is to note down is left subtree must have values. Left subtree will have the values. Left subtree will have the values which is less than the root, and right subtree will have the values which is greater than the root. This is the logic of binary search tree. And there will be two child nodes, which are having left and right child nodes, and left and right child nodes will have leaf nodes. So this is basic diagram or overview of binary search tree. Next thing to understand is the height. If you see the height of binary search tree which I have drawn, if you see the height of binary search tree. So this is first, this is second, and this is third, right? The height of binary search tree, there are basically two levels, one level and two levels. There are two levels of the height, and usually this is only the maximum height. You won't get more than this height. So binary search tree will be having this as a maximum height of the tree. And usually when you are doing any insertion or when you're doing any search of for any number, you will be giving the time complexity of the height. We'll come to that little later. Let's see the insertion of binary search tree. Okay, this is just an overview. So in the overview we have learned, we will write it. What is the overview? So in the overview, we have seen that binary search tree has left child, has right child. And also if you see, each node is carrying some value, which is very important for the presentation of binary search tree. Each node should have the value. So int value is also very important. So what all three things which are important for presenting the binary search tree are? Again, let me repeat. It consists of, first thing is, it consists something called as node, right? You can call this as a node or you can call this as a tree node. It consists of a tree node or a node. It is same only. I have shown you that is also called as a tree node. So it consists of a tree node which is a root, and it should never be empty. Okay, root should not be null, otherwise it's difficult to traverse also. And the tree node also consists of left nodes and right nodes. And another thing which it consists of is the value. This is the complete presentation or the overview of the binary search tree. Let's just, whatever we have learned, let's just put it in the code. So first thing is, we are going to create a class of binary tree, that is I'm naming as tree node. And then we are having int value in the class, and we are having tree node left child, and we are having tree node right child. These are very important things which we have in the class. Now see, what is a class? Basically class is something like a human body, right? You are a human being, I am a human being. So human being has some properties. What are the properties of human beings? Hands, eyes, legs. These are the properties which every human have. So same thing, a tree has the property, that is values left and right. Then to initialize that, we need a constructor. So I am creating a constructor. Now this is a default constructor. This is nothing but a default constructor. I will be creating another constructor with value, int value. So wherein this dot val equal to value. Again, I'll initialize with, again, I'll create a constructor to initialize my left and right child nodes. So, tree node left, tree node right. This dot left equal to left. This dot right equal to right. Yes, so this is what is the basic concept of the binary tree. And now next video we'll learn about implementation or insertion of binary tree, how we are inserting the in the binary search tree. So today I have given just a complete overview of what is binary tree. Again, binary tree is perfect binary tree if it has two nodes, that is left and right child, and the labels are all completely filled. If the labels are completely filled, it is again called as a full or a complete binary tree. And the logic, as you know, logic consists of left is always less than the root dot value. Left is less than the root, and right is greater than the root. Left is always less than the root, and right is always greater than the root. That's it for today. Let's see in the next chapter related to the insertion of binary search tree. Thank you for watching.